Okay. So in last few videos, we have discussed about law of motion and we discussed some examples related to those concepts. Now we are going to discuss common forces in mechanics. Okay, before that, we can classify all the forces in nature into four categories. That is another way. One you can say gravitational force, another electromagnetic force, and then one is strong nuclear force and weak nuclear force. So fundamentally, these are the four forces present in nature. But here we are going to discuss common forces in mechanics. And okay, one more way to classify the forces based on whether the interacting bodies are in contact or not. There we can classify these forces into two categories, where one is category of uniform contact forces, not uniform, contact only, contact forces, and another category we can write non-contact forces. So in contact forces, we have several examples like what we are going to discuss now. Friction. Thereafter, we know any body which is partially or fully immersed in a fluid experiences an upward force, which we call buoyant force. So buoyant force, this is kind of contact force. And so many forces are there like this, tension in a string, and the list will go on. Now, non-contact forces, for example, we have gravitational force, of course, a kind of non-contact force. So gravitation, and electromagnetic force, where we can say electrical forces because of charges, and magnetic forces also, the force between the poles of magnets. So we can classify this way also. But here in this particular video, we are going to discuss about friction, this one, which is a common force in mechanics. So let's move ahead and start friction. Okay, before coming to the classification of friction, okay, what is friction? So if there are two bodies which are in contact, or two surfaces, better to say, two surfaces which are in contact, and if there is relative motion between the two surfaces, or its tendency means they are trying to move against each other. So if this is happening, there will be force opposing this relative motion or tendency. Okay, so tendency uh, of motion which is not actually happening, we call it impending motion, means that would be, but it is not actually happening. So if there is relative motion or there is impending, so there will be a force which will oppose this relative motion or impending motion. So here we are using term friction. This friction is for solid surfaces only. Here we are going to discuss friction between solid surfaces. Yeah, there may be between a solid and a fluid, like an aeroplane moving through air. So that friction will be drag. We are not going to discuss about drag and viscosity right now, but yeah, we are going to discuss the friction. Okay, and this friction for solid surfaces, where the two surfaces of solid bodies are in contact, they are trying to move or they are moving against each other. So in both cases, there will be friction. Based on that, we will classify this friction into static friction or kinetic friction. So let's start. Okay, taking this situation, let's say there is a block of mass m. Here is the block of mass m, and this block is lying on a horizontal surface. This is let's say a platform, you can say. So surface. Okay, this box or block is initially at rest. So the net force on this block is 0. And what are the forces actually acting here? So just ignore this arrow for a moment, then we will come to its relevance here. So Okay, this block is at rest initially, let's say. So there are two forces acting on this block. One, gravitational force, which we call weight of the block. We can write gravitational force. This is nothing but m times acceleration due to gravity. But because of this force, there will be acceleration, and this block will start its motion downward, but it is not happening actually. And to stop its movement downward, this surface is providing a net force which has equal magnitude. We call it, let's say, call it normal reaction. This force, we call it normal reaction. And if this block has zero acceleration, means if it is initially at rest, now it is in rest, this should be equal to gravitational force. So there is a block, net force is zero here. Now what will happen if we are going to apply a force this way? Let's say this is applied force on the block. Okay, we will start this force from very little magnitude to high magnitude until the block starts moving on this surface. So if we are applying this force very little, and this block is and we know from our experience, if there is a block, let's say this block has mass of 20 kg, and if we are applying a force here, gentle force, this block may not move. And then what is the factor stopping this block from movement even if we are applying this force? This is a situation where friction comes into play. So what is happening if we apply a force here, let's say a very little force, this block is not going to move. And let me clear it, and then we can draw some more things here so that it will be obvious. So if we are applying a force here on this block, little force, and this block is not moving, that is, there is some force which is stopping it. That force is nothing but friction applied on the this bottom surface of the block from the surface of, yeah, this, you can say surface or platform, whatever you want to call it. So let's say it's a platform. So this block is not moving because there is a friction, and this friction is in opposite direction to this applied force. And if this block is not moving, it is in rest, then the magnitude of these two forces, that is applied force and the friction, these two should be equal. If there is net force, if they are not equal and there is net force, then there should be acceleration in this block. Okay, so let's say if we are increasing this force, let's say we have slightly increased the magnitude of this applied force, and this there may be a situation that even after applying little force, and then we are increasing the magnitude of force, still this block may not move. And that is the situation where this friction has a new magnitude. Let's say new force we are applying here, which is little more than this thing. Let's say F applied is slightly less than new F applied. So this friction, let's say new friction, and still the block is not moving. So this friction is equal to this applied force. So what is happening? If we are starting from a very little force, this block is not moving, we are increasing the magnitude of the force, and if still this block is not moving, which is possible if this block has mass of 20 kg and we are gently pushing it, and if we increase little force, still this may not move, and this will continue up to a certain limit. At a certain limit of applied force, if we are going to increase the magnitude of applied force, this block will start its motion. So up to that, if this block is not moving, this friction, we call it static friction because the block, these two surfaces, the surface of the block and the surface of this platform, these two surfaces are in rest relative to each other. So we have started from very little force, we are increasing the magnitude of force, still this block is not moving. It means this friction, static friction, has changing magnitude based on the applied force. And it is changing in such a way that every time it counters the applied force and it keeps the block in equilibrium. But at a certain limit, this force exceeds this static friction, and then this block will start its motion. Okay, up to that level where the maximum friction can be, that static friction, maximum static friction, we call limiting friction. And that limiting friction, we find it limiting friction. Let's write Fs max. This friction is proportional to the normal reaction. This one, proportional to the normal reaction. Let's say this normal reaction is n. We have discussed about this normal reaction just a few minutes before. So this is found experimentally. The limiting friction, that is a maximum kinetic friction here, sorry, maximum static friction, is called limiting friction, and this friction is found to be proportional to this normal reaction. And if this block is at rest, means there is no acceleration in vertical direction, this normal reaction will be equals to its weight, that is m times g. Now here we have proportionality sign. So if we remove this proportionality sign, there should be a constant multiplied. This constant we call coefficient of static friction. Let's say this is static friction, and its maximum value, we call it limiting friction, should be equal to some constant multiplied with this normal force. Here n is for this normal force, not for Newton. So this normal force, we can write it mu s into m into g. This is maximum value of static friction there. And this mu s, subscript s is used for static word. This mu s is coefficient of static friction. Okay. One more thing, this static friction depends, or even friction, not only static, maybe kinetic also. This friction depends on the nature of the surfaces which are in contact. It it doesn't depend on the surface area in contact. This is one point to be noted. Let's move to the next slide, then we can write some points there. Okay, here we can write this friction is independent of area in contact. Okay, and second thing, in case of kinetic friction, which we are going to discuss, there it will be independent of velocity. Yeah, this is specifically in the case of friction between solid surfaces. It is not the same case when we discuss about drag or viscosity. It is not going to be the same. There, in case of drag, there will be dependency on velocity also. So that is matter of another time. Here we are discussing about the friction between the two surfaces, and these two surfaces are actually surfaces from solid bodies. So, okay, here we have a diagram. What is happening? Let's say this is friction, and this is applied force. What is happening actually? If we are increasing applied force this way, look, the graph is going upward, the friction also increases. Okay, so with increase in applied force, friction is also increasing, and it is increasing up to a certain limit. Here we can see here up to certain limit. This maximum value, look, in this region there is no relative motion between the surfaces. So here we are dealing with static friction. In this region, this plot is representing the static friction up here. And this maximum value, we have just talked about it. This is nothing but limiting friction. Okay. Once the force which is being applied on the body Once the force exceeds a certain limit, the body starts its motion. And if it is in motion, still there will be friction, which we call kinetic friction. And this kinetic friction is now constant. It doesn't depend on the movement of this body. So what happens actually? And of course, this kinetic friction is slightly less than this limiting friction. This all things are verified experimentally. So we can write here kinetic friction. And this kinetic friction is constant throughout motion, and it has value slightly less than this limiting friction. So you can connect here to a point. This is kinetic friction. Okay, let's discuss a little more about this kinetic friction. As this body starts its motion against this surface, and if these two surfaces are in contact, there will be friction, and this friction we call kinetic friction. And it is found that this friction is independent of the velocity of this body or the surface area, of course, which are in contact. But this friction depends in the same way on this normal force, which is being applied by this platform on the lower surface of this body. Okay. Here, if we want to remove this purposelity sign, we are going to multiply some constant, and then this way we have another relation for kinetic friction. And in the same way, this mu k stands for kinetic term. This mu k is coefficient of kinetic friction. And let's do some points here. Okay, there should not be any confusion about the static friction and its maximum value, that is limiting friction. Okay, static friction can take any value between 0 and this maximum. We can see it from the graph also, and this is very intuitive because look, if we are trying to push this block and we are starting from a very little force, and if this block is not moving up to certain limit, so during that span, at each and every point, the applied force is balanced by this friction force. And if we are changing the magnitude of the applied force, it means the friction is also being changed. And this is what I'm trying to say. And this friction, of course, we call it static friction. This is what I'm trying to say here, that this static friction can take value up to here. Once it reaches its limiting value, that is maximum value of a static friction, the block will start its motion. And then now these two surfaces are in relative motion against each other. So still there will be friction, and that friction we call kinetic friction. The value of that kinetic friction is slightly less. These all things have been experimentally verified actually. So during motion, there is a constant friction, that is kinetic friction. This region we can call, this region is for kinetic friction.